So I've had quite a few queries on how to use the VertexArrayObject class. So I've added another couple of demos onto the VertexArrayObject NGL demos here. There's a new one called Changing VAO and one called Per Frame VAO. And what these do is they both demonstrate different ways of visualizing data that changes every frame, which seems to be a big issue at the moment. So I'm going to start with the Per Frame VAO demo. So what I've got here is a stood vector of NGL vec3s called mdata, and this is basically going to be resized every frame on a timer event and populated with three-dimensional points basically. And then what I'm going to do is every time that changes, I'm going to render that changing VAO. And unlike a lot of the other demos that have static VAOs, I normally have an attribute called mVAO. In this case, what I'm going to do is create one every time I need it. So first thing, when the program starts, I have a timer that's kicked off, and my timer event here, first thing it does, it clears the VAO, so it resets it. I'm getting an instance of NGL random here just so that I've got something to generate my random numbers, and I'm resizing the data here 2 times random positive number 500. So I'm making sure that I've got an even number each time so that I can draw lines. And then nice bit of C++11. So for each element in that array, get a reference and set it to a random vec3 and scaling it by 5. And then I call update, which is obviously going to trigger drawing. So this is where the drawing is going to happen. I've got paint.gl here, and you can see now that I'm creating a vertex array object pointer called VAO as GL lines. To do anything, we must bind it, so we call the bind method. Now I'm calling setData to copy the data across from my stood vector into the VAO. So setData will just copy mdata.size because that's how big the array is, and obviously this is in bytes, so we need to take into account the fact that each element is an NGL vec3, so obviously that's 3 floats, so we've got on this machine 4 times 3 bytes times the size of the array. And this is one of the areas where you may have issues that you forget that this data is in bytes, so this size is in bytes. And then the pointer to the first element of the data, and that's just dereferencing the first element there. We then have to set the vertex attribute pointer to say how the data is laid out, and again this is an important thing. If this is not called, then internally OpenGL doesn't know that that's set, and also OpenGL will fail to enable that vertex attribute, which means it doesn't get into the shader. Then we have to tell it how much we want to draw. So in this case, mdata.size is the size of the array, that's how many elements we want to draw. We then call draw, then unbind, and again this is important because we're not going to use that chunk of VAO memory again, so we must clear it every time we finish. So we must call remove VAO. Now obviously there is a dangling pointer here, but as that pointer the only resource it has, because we can't call the destructor on the VAO because it's managed, so remove VAO is the important thing, that it just basically clears that. The pointer goes, but there's no resource allocated with that. So if I run this now, you can see that it runs off, and you can see that I'm just generating dynamically different sizes of data each frame. You can see the size there, and it just goes and changes each time. There is an overhead with doing this, because obviously I'm recreating a VAO every time. It's not particularly slow, to be honest, and it's quite a common thing that if you have to create dynamic data, you can do this. If in advance you can think how big your data is, you can do some other optimizations by just creating data, mapping the VAO and updating the data. There are other demos online that do this as well. But for most simple visualizations, you will not see too much of a problem doing this sort of creating a VAO per frame. You can see it runs quite quick. It's running quite slowly because of the timer. If I update the timer to be as quick as possible, you'll see that it is pretty quick how often that does, so you haven't got too much of an issue there at all. So that's the first demo. The next demo, slightly different, that what I'm going to do is now have the VAO as a class attribute. So the VAO is there. I'm storing it in a stud unique pointer just to ensure that it's managed correctly. So there's my MVAO there. Then when I start up my initialized GL, so I create my basic GL. You can see here I'm just resetting that, creating a new VAO with lines. That will just set that up as normal. The creation of the data is exactly the same as it was before, but now when I draw, I'm basically referring to the VAO here. So we bind the VAO, I call set data again, so it's exactly the same as before, it's just updating and binding that data. This is important. If we don't call this set vertex array pointer, again, it won't work. And it's interesting because you think that you should be able to, when you create the VAO, say this data is here. However, that doesn't work and it needs to be set each time in this. Again, it's working as before, more or less the same sort of thing. And you can see that, again, there's very little change in speed or other advantage in doing either way. So if we run this through, you can see, again, it's still very fast, it's just one less call. So you should be able to do that with your projects now, and hopefully that will make it easier. The code's on GitHub. If you have any other queries, just send me a mail.